Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face Trending List, published on October 8, 2025, about 3 days ago. The standout finding is a hybrid mechanism that turns on latent reasoning in base models, recovering up to 91% of the gap to thinking models while steering only about 12% of tokens. The paper is titled, "Base Models Know How to Reason, Thinking Models Learn When," and the implications for model training are quite significant. In short, this paper argues that thinking models learn timing, supported by unsupervised sparse autoencoder discovery and steering vector control, closing gaps on GSM8K and MATH500 without weight updates. Alright, the previous segment laid out the core claim about timing. Figure 1 shows the hybrid loop in action. The base model writes most tokens, while a thinking model evaluates each step and classifies the next reasoning category. The classifier favors backtracking at about 85%. So a steering vector is applied to the base model's activations. That nudge prevents a premature answer and instead yields a wait step, which keeps the reasoning chain on track. Well, Figure 1 showed the hybrid loop. Figure 2 now presents a grid search of sparse autoencoder taxonomies across 5 thinking models. Each heat map scores layer location against the number of clusters, where blue marks stronger interpretability, completeness, and independence. The best regions cluster around mid to late layers and reach about 70 to 80%. An elbow appears around 10 to 20 categories, which supports choosing roughly 15 to 25 reasoning mechanisms. Okay, the previous figure mapped the taxonomy space, and Table 1 reports what that buys on GSM8K. The hybrid boosts Llama 3.18b from 37.8% to 63.4%, which recovers about 56% of the gap. Human 2.532b with DeepSeek R1 Distill reaches 94.4% and recovers 82% of the gap. Pairing the same base with QWQ32b peaks at 96.4%, while the tiny 1.5b case shows no recovery. So Table 2 reports MATH500, showing how the hybrid approach lifts accuracy over the base models while stopping short of the thinking models. The strongest case pairs QN 2.532b with QWQ32b, reaching 84% and recovering about 91% of the gap. Mid-size QN 2.514b and 32b with DeepSeek R1 Distill gain roughly 15 points, which signals solid latent skills. The tiny models show only 2 points of lift, suggesting weaker or noisier steering directions. So the previous table covered accuracy, and Table 3 shows how often steering actually fires. The table reports the average fraction of tokens steered per problem, which stays low across pairs. The typical rate sits around 10 to 13%, the highest case reaches about 22% for Llama 3.18b, and the lowest is about 6.5% for QN 2.514b. These sparse nudges suggest precise timing, not blanket control. Alright, the previous table showed sparse firing rates. Figure 3 illustrates how those few nudges play out on a single MATH500 problem. The left panel shows the base response, which proceeds linearly and stops once the distance is written without organizing the reasoning. The right panel shows the steered response, which injects clear sub-goals, explicit differences, squaring, addition, and a simplified radical, so the steps stay coherent. The final answer remains correct, while the path becomes more structured. Wrapping up, 2 takeaways stand out. Base models already contain strong reasoning mechanisms, and thinking models mainly learn when to trigger them. The hybrid steering approach closes most of the gap, while nudging only about 12% of tokens, which points to cheaper training that teaches timing and activation control. Thanks for listening. I am Alex, and this was the AI Research Roundup.